Dear friends, welcome to today's video clip number V9 2204 MA 8 by YouTube video channel BIOLIMATECH. As a matter of fact, this evening we shall discuss a rather peculiar problem. It's nothing to do with working out a problem. It is something else. We all know that factorizations are always there in questions of algebra in school level. But one problem very often comes that a host of the polynomials given for factorization keep confusing students because of their vague similarity in appearance. What kind of similarity? Mostly they all contain the same number of terms. They all contain one constant term and some such other features which make them look alike polynomials. But each one of them for factorization will call for definite and specific formulae and technique. Suppose we are not able to pick the right one or identify the right one at the right moment. What happens? Ultimately, after some time of fiddling, one is able to find out what kind of problem it is, which formula it demands, and he will be able to solve it. But by that time he has already wasted the time that he would have given to two other good small problems. So we shall try to identify some tricks or techniques which we need to employ in order to pick up the right type of problem. Thank you. We shall proceed now. So, my dear friends, we are right up in front of a board where we have tried to create a kind of a table so that we can illustrate our findings today. Well, we start with taking up 4 polynomials as samples. The first sample is a polynomial containing 3 terms. Second sample is also a polynomial containing 3 terms. Third is also 3 terms, and fourth is also 3 terms. The first sample is x cube minus 19x minus 30. Second is x to the power 4 minus 7x square plus 1. Third is x to the power 6 minus 18x cube plus 125. And fourth is x square minus 5x minus 6. So I question back, what is the total number of terms present in all the 4 sample polynomials? We find in the first sample, total number of terms is 3. Second, total number of terms is 3. Third, total number of terms is 3. And fourth, total number of terms is 3. So total number of terms is 3 in all the cases. So this is one vague similarity, and this can create some confusion. Next we go to how many numerical constants are there in each polynomial. In the first one, there is one numerical constant, that is minus 30. In the second one, there is one numerical constant, that is +1. In the third polynomial, there is one numerical constant, that is +125. And in the fourth one also there is only one numerical constant, that is -6. Well, then we focus our attention to, so this much about the confusing aspect. And now our ways and means to find out the right way, to pick up which type of polynomial we have to deal with. That is the identification part. In this identification part, our first activity will be to calculate the ratio. What ratio? Power of x in the first term divided by power of x in the middle term. In place of x, it could be a, could be b, whatever it is, it's the variable. So power of the variable in the first term divided by power of the variable in the middle term. See, in the first case, x cube minus 19x minus 30, power of x in the first term is 3 and in the middle term it is 1. So the ratio is 3. In the second polynomial, it is 4 and 2. The ratio is therefore 2. In the third, the first term power is 6, mid term power is 3. So again the ratio is 2. And in the fourth polynomial, the power of x in the first term is 2 and in the mid term it is 1. So again the ratio of the powers is 2. So number of perfect cubes, how many are there? In each polynomial, how many terms are perfect cubes? In the first one, we see only x cube is a perfect cube. In the second term, we find there is only the numerical constant 1, that is a perfect cube, but it could have been some other numerical constant too, which might not have been perfect cube. So, question of perfect cube does not appear here. Well, in the third one, x to the power 6, it is a cube of x square, and 125, it is the cube of 5. So there are as many as 2 perfect cubes in the third polynomial. And in the fourth polynomial, there is no perfect cube at all. And from these findings, we can immediately say that when the ratio of power of x in the first term to the ratio of power of x in the middle term is 3, it's a trial method. That is where you have to find out the zero of the polynomial function, and then by putting x plus minus that value for which the polynomial becomes 0, that is a factor, and find out the rest one. The conventional trial method of solution, or the vanishing factor. In the second case, this is a case of x square minus y square, that is difference of two squares. The third case is a singular thing where we have found there are 2 perfect cubes. These are undoubtedly of the formula x cube plus y cube plus z cube minus 3xyz. And the fourth one, x square minus 5x minus 6, is purely a middle term break, the most ordinary type of factorization. So, in today's video, we are not going to do anything about the actual solution of these factors, working out of these factors, but only we have taken samples and found out ways and means to identify which type of formula will be applicable for which type and what will be the criteria for identification. That's all. Thank you.